Okay, so let's get started. So there should be some links in the chat to the sort of workshop website. Okay, so the link to the slides are there if you want to follow along, and there's also going to be some exercises and things for you to work on. So welcome, and as Crystal's already said, so I'm a data viz specialist. I've been working with R probably for about 10 years, and now I mainly work with some R, some Python, and more recently with D3. So my background is in statistics and data science. So during this workshop, there's going to be a combination of some slides and me talking. There's going to be some live coding examples, some demonstrations, and then there's going to be some exercises for you to participate in so you can actually properly get started working with Git and GitHub today. Please do feel free to ask questions in the chat throughout. I will try and get through as many of them as I can, and I'm very grateful for everyone who's helping to answer questions. When you're working through your exercises, I'll also get to work on answering some of those questions if there's any left. Okay. Having said that, I kind of hope you end up with more questions than answers after this workshop. It is very much an introductory workshop. There's lots of things that we're not going to have time to cover in 2 hours, but I hope you at least start figure out what kind of questions you want to be asking. So all of the workshop resources are on the workshop website. Okay, so like I said, slides, all of the examples I'm going through as well. There's some screenshots and some notes there as well. So if you miss something or you want to look back at it later, it's there. There's also some exercises and there's also some additional resources as well. So if you want to sort of go and read a bit more about something in particular, there's some useful links there. So let's get started with a general introduction to Git and GitHub for R. Okay. So I wanted to start with a little bit of motivation for why on earth you might want to think about using things like Git and GitHub if you're an R user, right? So I want you to imagine this scenario that I'm hoping might be quite familiar to a lot of you, okay? So let's say you've written some code and you want me to review it and have a look at your code. And so you send me your code in an email, right? And you call it something like code.r. And I go through it. Maybe I make some changes or I add some comments or I have some thoughts. And I email you back an R file and I sort of add an underscore comments from Nicola comment to the file name. And then a week goes past. You do some more work, you add some more changes, and you want that reviewed as well. So you send me a different file. It's called code version 2. And then I add code version 2 with comments and so on. Okay. And gradually we both just accumulate large numbers of R files. And it's really hard to keep track of them. So this is one of the motivations for using things like Git and GitHub. Okay. So Git is a version control tool that you install on your laptop. So it's something that just works locally on your machine. Okay. GitHub is a sort of place to host code online. Okay, so an online Git repository. And that lets you share code with other people and work together on it. Okay? So you can use Git without GitHub if you want, if you're just working on something by yourself or something that you maybe aren't able to put online. You can use Git just on your laptop. You can also use online repositories that are not GitHub. Okay, so GitLab, Bitbucket, Codeberg are some good alternatives. GitHub is, at the moment at least, the most common, and it is the one we're going to kind of focus on today, mainly because there's a lot of resources out there on working specifically with GitHub. So if you're using GitHub or another online repository tool, what that lets you do is keep track of different versions of your code and the history of your code without keeping multiple copies. Okay? So it's a little bit like track changes in a sort of Word document. You keep track of different versions, but you don't have to keep sort of doing version 1, version 2, final version, and so on. It also lets you keep track of all changes, okay, even after they're accepted. So this is one of the things that I really like about Git. So if you were doing track changes in, let's say, a Word document, once someone makes those changes and someone accepts them, what it looked like before, who did it, and when they did it is sort of quite hard to find, if not impossible. Whereas if you're using Git, you can see when's the last time this file was edited, who edited it, what did they change, and so on. So it gives you this sort of full history of everything that's happened. With GitHub, you can also ask someone to review your code. So rather than sending them a file by email, you can sort of send them a request through GitHub. They can add some comments, they can ask questions, and they can suggest changes. And again, it keeps that full history. So if someone has suggested a change, you can see what it was that they were suggesting and maybe some comments and discussion about why they were making that suggestion. You can also, if you're kind of a very organized person, you can use GitHub as a project management tool. So you can sort of make issues. Okay, so essentially a big long to-do list. So if you love ticking things off a to-do list, issues are your friends. You can also set deadlines. Okay, so you can sort of say, okay, we need all of these things done by this date, and then you can gradually tick them off and see how close you are to meeting that deadline. We can also get GitHub to do some things automatically. So things like linting, so making sure your code follows a particular style guide or making sure that it passes any tests. We can get GitHub to run those automatically. So you can sort of offload some of the tedious parts of writing code to GitHub and run it from afar. Okay. And you can use GitHub either on your own or with other people. I would quite strongly recommend practicing on your own first, okay? Because when you go into sort of a company that's using GitHub quite a lot and you're sort of thrown into using it in a team and with other people, it's really nice if you're already a little bit familiar with it just on your own. And you can benefit from a lot of these sort of features of GitHub, not just sharing code with other people. So we've talked a little bit about sharing code with sort of maybe other team members or people you want review from. You can also use GitHub as a way to share your code with the rest of the world, however scary that might seem. Okay? But you can write your code in private. Okay? So you can keep it just for yourself or for your team, and then decide at a later point when you're sort of ready to make it public. So, for example, if you're working in academia and you're writing a paper and you want it to be sort of nice and reproducible, you can write all of your code in private. And then when you're ready to make it public and sort of submit it to a journal, you can make the GitHub repository public and you can have your code reviewed. Okay? Some of the other sort of nice things that come with GitHub is the ability to add a license file. So that explains how other people are allowed to use your code. And we'll go through some examples today of using things called git ignore files and GitHub secrets, which help make sure that you never accidentally upload something you shouldn't. Okay, so maybe something like data or something like passwords or sort of API keys. We don't want to share those with the world. And we've got some nice tools to make sure we don't do that by accident. So let's talk about using Git and GitHub with RStudio. Okay, so if you're going to be sort of joining in with the exercises and things today, what you're going to need is RStudio and Git installed on your laptop. You can use other IDEs, sort of like VS Code or Positron if you like, but the examples I'll be doing are in RStudio. If you're struggling with any of those steps, particularly in terms of installing Git, if you go to the Happy Git with R book, which is also linked on the workshop website, it will give you some more specific instructions depending on what operating system you're using. Okay, if you are having massive issues with installing Git, do drop a message in the chat and we'll do what we can. Okay. You will also need a GitHub account. Okay. Um, if you don't already have one, you can just go to github.com. Okay. And if you don't already have an account, just stick your email address in and pick yourself a username. Okay. And again, I think the Happy Git with R book has a nice little section on choosing a username because it's one of those things that you will pick on step one and then have to live with for a while. So do get yourself a GitHub account if you want to join in and you don't already have one. What we're also going to need is some GitHub credentials, and that's sort of the first demonstration we're going to do. Okay, so basically, how do we effectively create a password that lets our laptop talk to GitHub? Some other things that we'll be using is the use this package. Okay, it's a really, really useful R package that makes a lot of the working with Git and GitHub things a lot easier. Okay, there's always an alternative way to do it, but I found that the use this package just makes it nicer. Okay. Finally, the other thing that I strongly recommend you use is the Happy Git with R book. Okay. So this is a really, really useful book by Jenny Bryan, and I almost always have this open whenever something in Git isn't quite working, or if I'm doing something new, or it's being a bit weird. I kind of always have this open. Okay, so anytime I'm doing something like installing Git on a new laptop, it's kind of there as my instruction manual. Okay, so let's start off with a little bit of a live demo. Okay, so I'm going to hop over to RStudio. Okay, my setup's maybe a little bit different, so just to note that the console's up here on the top right rather than the bottom left here. Okay. So first thing that we want to do is make sure the Git is talking to R. Okay. And again, there's different ways you can do this. The easiest way I find is to head over to the terminal. So the little tab just next to the console. Okay. And if you type in Git, okay, and then dash dash version, okay, if you get a message that says Git version whatever, it's working. R and Git are speaking to each other. If you get another message that says sort of Git not found or sort of command unknown, that means that Git and R aren't quite talking to each other yet. Okay? And the reasons why Git and R might not be talking to each other will probably heavily depend on your operating system and sort of how things were installed. Okay, so if you are getting that message, first thing I'd suggest is have a look at the section on Jenny Bryan's book on Happy Git with R, on installing R and getting Git talking to R. If you're trying those solutions and it's really not working, stick a message in the chat, and again, we'll try and help as much as we can in this situation. Okay. So then what we're going to do is we want to configure our GitHub account. Okay, so assuming that we've got Git installed and it's talking, what we want to do is sort of set up what's our username and what's our email address. Okay, so the easiest way to do this is again using the use this package. Okay, so if you do library use this, and then there's gone over here, use git config. Okay, and then we have two arguments. One is user.name. Okay, and in here you're going to put in your GitHub username. Okay, so when you're creating your GitHub account, whatever you picked as your username, that's what we want to put in here. Okay, so mine is just nrennie. And then we also want to set up our email address. Okay, so you do user.email equals, and you type in whatever email address you use to create your GitHub account. Okay. So then when you've run that, that basically sort of sets up you to use Git and GitHub from within R. Okay. Then what we need to do is create something called a token. Okay. So again, easiest way to do it is using the use this package. Okay. And our really sort of nicely named functions is create GitHub token. Okay. So if you run this, what should happen is that it will open up GitHub for you. Okay. And if you've set up two-factor authentication, it's gonna give you a little prompt. If not, you might have to put in your password. Okay. Okay. And you should get a screen that looks a little bit like this. Okay. So it's basically a screen that lets you create a new, what we call personal access token. Okay. So it's a little bit like a password. So there's a couple of things, well, lots of options actually that you can choose. What I would suggest is that if this is your first time kind of using Git and GitHub, leave the defaults. Okay, the defaults have kind of been picked from the use this package as in the ones that are most likely to be helpful. Okay. You also want to give your token a bit of a description. Okay, so what I usually do is give it a name that relates to the sort of laptop that I'm kind of using with it, so I know which token is being used where. You should also set an expiration date. Okay, so as you'll see from the dropdown, the default is 30 days. You can, if you want, choose no expiration, but I will leave that entirely up to you. Okay, so it's essentially thinking about how often should you be forced to change your password. Okay, it's more convenient if you use no expiration, but in terms of security, that's bad. But you can make your own choices about that. Okay, so once you sort of picked these options and given it a name, if you scroll all the way down to the bottom, you can click on this green button that says Generate Token. Okay, and what that does is it will generate a sort of long string of letters and numbers, and that is essentially your password. Okay, so you want to keep that very safe. You don't want to share it with anyone else. So I'm not going to click on the generate token for me at this point in time. Okay, but it'll generate a token and you can copy it. Okay, and once you've copied it, what you want to do and what you actually get prompted to do as soon as you run this create GitHub token function is call git creds set. Okay, so you can do library git creds. Okay, so for GitHub credentials, and then do git creds set. Okay, and when you run that, okay, it will, if you don't have GitHub credentials, you can paste your new one in, okay, or you can overwrite existing ones, okay. So I already have my GitHub credentials set up, so I'm going to cancel that, okay. But you should be able to set and paste in your own personal access token, okay. And hopefully you won't get any error messages, okay. And that's essentially us ready and kind of got everything set up. Okay, so we know that Git is talking to R. We know that we have a GitHub login. R knows what our GitHub username and email are. We generated our token and we've pasted that into R. Okay, and the nice thing about using git cred set is that it sort of keeps that that token kind of nice and secret and hides it for you. Okay, so after you copied it and pasted it into git cred set, you don't need to keep it anymore. You don't need to keep a copy or remember it. Git creds kind of does that for you. Okay. So if I head back to some slides, okay. It's basically your turn. Okay. So you might have been following along with those exercises. If you haven't, and you're just kind of watching, that's absolutely fine. There'll be some time now to work through it. Okay, so go ahead and make a GitHub account if you don't have one. Install use this and Git creds if you haven't installed them already. Configure Git, run create GitHub token, and then sort of follow through the instructions. Okay. If you're getting really stuck, have a look at Happy Git with R. Okay. There's a sort of personal access token page there, and you'll see some common errors and things as well. Okay. Um, I'll give you a little while to do that. If everybody's feeling sort of happy and confident with that, just sort of drop a message in the chat to say you're sort of ready to move on. Okay, and I'll have a look and see if there's any questions.
While we're doing this, Nicola, there was a question earlier from Sophia that I think our group has answered, but you're welcome to respond to it more.
Yeah, so we're going to talk a little bit about our project files next, because if we're using Git with R, we actually kind of have to use projects. So we'll talk a little bit about sort of project structure. I don't think I'll mention it here, but I might link you to some other materials about things like using relative file paths and sort of writing down where you've put stuff. So, you might not want to upload all of your Quarto or R Markdown outputs. You might not want to upload all of your data to GitHub. You might just want to upload the code. What the person you're reviewing can do is then sort of get a copy of your code from GitHub onto their own laptop and run it locally to create the outputs. That's quite helpful in terms of making sure that someone else can reproduce it, that someone else can actually run it. Um, and again, sort of using those tricks like relative file paths and sort of writing down, okay, where have you stored your data? And sort of just writing down how that person should run it. So it is really important, and I think Crystal's actually a really good person to ask about this stuff in terms of organizing projects and sort of writing stuff down and documenting it. You don't have to upload absolutely everything, including all of your data and output, to get a review. You sort of you can, but you can just send the code as well. And it depends a little bit on what your code is and how complicated it is, whether you actually do need to run it or if you're just making small changes, um, then yeah, you might not need to rerun it.
It looks like Holly also had a question in here, Nicola, that Livy answered as well, but you might have some more feedback.
Yeah, so the question's on will R automatically prompt you when you need a new token. Um, I don't think it automatically prompts you, but it will just stop working, and that's kind of the prompt. So if your token expires and you try to use it from R, you'll get a message that sort of says like can't authenticate, or sort of it might tell you token expired. I can't quite remember. Um, but when you get that, you can kind of just go in and look at your personal access token. I know that I get emails
Yeah, I
from
was gonna
GitHub if
say,
I've set
I
up a
was
personal
dreading
access
email.
token. Yes, and it's the email that you get and you ignore for longer than you should, because you can set up you sort of regenerate a token when you get the sort of it'll expire in 1 week notice, or you can let it expire and deal with the problem when it hits.
Nicola, it doesn't look like you ran the timer, but I've
Okay,
been watching. We're like, I think 4 minutes in, so.
okay, perfect. Yeah, I think the other thing to sort of follow up on Livy's comment is when you went in to generate this sort of personal access token, you check certain options. So if you were trying to do something from R that needed some of these additional permissions that you hadn't given to that token, um, you might need to go in and generate another one at that point. Um, but generally speaking, I think that's been a very rare um, thing for me. And on GitHub, you can do um, things called fine-grained tokens, so you can give very specific permissions to a very specific project to avoid you having to give all of these permissions to every single project as well if you wanted to. How are we getting along? Do people want a little bit more time to set this up? I'm not seeing any error messages coming through in the chat, which is always a good sign.
Yeah, maybe people can give like a thumbs up or something if you feel good to go. All right, Krista. If you have any questions, please let us know.
I was trying to copy the error message, so I'm getting unexpected input in use get config. Am I supposed to have quotes around the username and emails?
Yes.
Okay.
Yeah.
I don't know why it doesn't like what I entered there. So step one is the use get config and then set, step two is get creds set. Is
So
that
you would
right?
have sort of three pieces of code. So you'd have use git config,
Okay.
then create GitHub token,
Okay.
and then git creds set, where you would
Okay.
paste in the token you make.
Okay, thank you. I think I maybe got them out of order, so let me try again. Thank you.
Nicola, you have a question here.
Yeah. Um, it's usually for a specific computer. So the question is on it, are these sort of tokens that we're making, are they for a particular project or a specific computer? Usually for a specific computer, you can make them for a specific project and computer combination if you want to. So if you need sort of slightly more permissions for one project, you can make a separate token for that one. But I know I have multiple tokens for sort of different laptops. So I've got sort of one for my work laptop and one for my personal laptop. So just kind of, yeah, keep them separate. And Louis posted some really useful advice in the chat as well. Okay, so you can use git sitrep. Okay, so then that will give you a little report to see if things have started to work correctly. So if your name and email have been added correctly when you did use git config.
I think it's been about 10 minutes, Nicola.
Yeah.
And then Krista,
So I think
struggling, we can keep chatting as well to kind of work through it.
perfect. Okay, so if you are having any more issues, do drop a message in the chat if you're getting really stuck. So what we're going to talk about now is creating and cloning a repository. Okay, but before we do that, I want to talk very, very briefly about projects. Okay, so when you're working in R, you may or may not be working in a project. Okay, so R projects are basically a special type of file. Okay, so they have this .r project extension, and they're really useful because it helps you keep all of the sort of data and the code and the outputs for a particular project in one place, rather than having that sort of one big folder that's just got all of your R code for absolutely everything in one sort of directory. Okay, so if we're working with Git in R, we're actually kind of forced to use projects. Okay, so I wanted to just do a very quick sort of recap or introduction to projects. Okay, so if you're in RStudio, you go File, New Project, and it does usually take a little second. Okay, and you'll see three options. Okay, so if you're not working with Git, okay, you can choose New Directory, and this just makes a project somewhere on your laptop, and you can write your R code there. Okay, what we're going to be doing is using one from version control. Okay, and if you click through that, okay, you're going to have a couple of different options. We're going to go with Git, and you should have this screen here. Okay. So I've said the word repository a few times. Essentially, when you're thinking about repository, that's your sort of collection of all of your code and everything you're sort of putting in GitHub. Okay, so I'm going to make it a little bit more complicated and talking about two kinds of repositories. Okay, we have local repositories and we have remote repositories. Okay, so the local one is what's on your laptop. Okay, so you can have just a local repository. Okay, so you create your local repository, you write your R code, you make your outputs, and that's all happening on your laptop. And then at some point, we want to put that onto a remote repository. Okay, so a remote repository here is going to be GitHub. Okay, so we want to take the code that's on our local machine and send it up to GitHub. Okay, and then it might happen that someone else, or potentially you from another laptop, make some changes to what's on GitHub, and then we can bring those changes back down to your laptop. Okay, so we have this sort of push and pull idea where we're sort of pushing code and pulling it back down between locally on your laptop and remote on GitHub. Okay. So what we're going to do is we're going to create a GitHub repository. Okay, so on github.com, then we're going to create a new R project for our repository for our code locally, and we're going to clone the repository. Okay, so cloning the repository is usually your first step. Okay, so that's where you take what's on GitHub and basically clone or make a copy onto your laptop. Okay. So let's head to GitHub. Okay. So if you head to, oh, I can't spell my own name. There we go. Okay, so if you head to sort of your profile page, okay, and click on repositories, okay, click new, okay, so it should be green, okay, and then you see this create new repository screen, okay, and you need to give your repository a name, okay. So I'm just going to call this Git demo. You can call it whatever you like, okay, you can call it the same thing, entirely up to you, okay. There's also some other options. So the one you probably want to think about most is this public or private. Okay, so by default, public is sort of selected. So that means that anybody on the internet can see your repository. If it's private, then essentially only you can see it or people that you add specifically to it. Okay, I'm going to keep it public so that you can all have a look at that. You can have a look at the repository if you want to. It's entirely up to you whether you choose a public or a private repo at this point. I think if you can make stuff public, if there's no reason not to, I think it's nice. It's a nice way to kind of build up a portfolio of code, but it's entirely up to you. Okay. So once you've done that, you can click Create Repository. Okay, and you might see a screen that looks like this. Okay, so it doesn't look particularly pretty or particularly easy to interact with. Okay, but the bit that we're interested in is this part here. Okay, and we're going to copy that. Okay, so the bit that says sort of github.com, your username, and then your repository name.git. Okay, you copy that, click there, and then head back to RStudio. Okay, and we're going to make that new project. Okay, so we go File, New Project, just to recap. Okay, go Version Control, and then Git. Okay, and you want to paste that URL into the repository URL. Okay, so you're taking this URL here and pasting that in to the top line. Okay. By default, the second one gets sort of pre-populated for you. Okay, so this is basically when it makes the computer, the folder on your laptop, what's it going to call the folder that it puts it in? Unless you have a good reason otherwise, I keep it the same name as the GitHub repository. Okay. The other thing you can do and should do is choose where you're going to put that project folder. Okay, so you can click Browse and you can go through. I'm just going to stick mine in Downloads folder. The main thing that's important is that you know where that folder is. Okay, so browse for somewhere to keep it, and then put it there. Okay, and then click Create Project. Okay, and it'll should actually happen very quickly for change. It will sort of relaunch RStudio. Okay, and you might notice a couple of things that are different. So one, you should see in the sort of top right-hand corner. Okay, you should see a sort of the name of your project. Okay, so it's called Git demo. And the other thing that's kind of crucial is that where you have your environment tab, if you go along, there should now be another tab that wasn't there before called Git. Okay, and if you sort of click on that, you might see that there's some things in there. Okay, and that basically means that on our laptop, we now have a copy of the sort of Git repository, and in my case, in my downloads folder. Okay, and when you clone repositories using RStudio, it very helpfully creates a couple of useful files. Okay, so that's kind of what these are. Okay, so the .r project file gets created when you make a project. And this .gitignore file that we will come back to in a little second gets created for you when you make that repository. Okay, so if you haven't already, if you've just been watching, I think if I remember correctly, is essentially your turn. Okay, so go and create a GitHub repository. Name it whatever you like. make it public or private, up to you. Create a new R project and then clone that repository. Okay, so when you kind of get to this stage, we're kind of ready to go with the next part. Okay. Again, same as before, if you get any error messages, do just sort of let us know.
Nicola, did you see the question in the chat?
Yeah.
Okay.
So can you set up a project between RStudio and VS Code? So are you creating create my repo locally? So you create just a local repo with VS Code and then transfer it to GitHub later. Yes. So if you I tend to go create the GitHub repo first and then add add the code after that, but you can do it the other way around. Let me just find the link to Happy Git with R. It's on. So if you go, there's this kind of section that says Get Started with GitHub, which is new project GitHub first, and that's kind of what I've gone for here, right? We're creating a brand new project that we haven't written any code for, and I start with GitHub. The other option is that you already have some code somewhere. I want to make GitHub and then add it to GitHub. Number 17 sounds like chapter 17, where you have an existing project. So you have a local project and you're adding GitHub last. So I'll drop that link in the chat. And it kind of goes through how you can do it from GitHub. Okay. There are I've kind of been using RStudio and keeping everything within RStudio here, but there are other pieces of software you can use to clone GitHub repositories. So VS Code is one. It's quite nice because when you open VS Code, it kind of initially prompts you with the do you want to clone a GitHub repository? So it's really easy to just click yes. But there's also GitHub Desktop, which is kind of like a nice user-friendly interface to clone GitHub repositories. So that's quite nice if you're working with things that aren't necessarily code. So if if you just want to change an image that's uploaded on GitHub, you don't necessarily want to have to open up RStudio just to change an image file. So GitHub Desktop can be a nice option for that as well.
I think as you're doing this, if you want to give us a thumbs up if you're going smoothly and you're getting done early, just to kind of let us know how the pace of everything is going, that'd be helpful. And also just drop any questions in the chat. Ooh, we already have some people done.
Great. So I will say that what we're going to be doing next is actually adding some code. So I will have some code or some data files that you can download. But if you have your own, feel free to sort of dig those out and have them at hand if there's something you're thinking you might want to put on GitHub. Okay. We feeling ready to move on? Okay. All right. So we're now ready to think about committing and pushing changes. Okay. And don't worry if those words don't really mean very much at this point in time. Okay. So committing files is basically where you've made some change and you want to make a record of that change. Okay. So I quite like this analogy of Git commits being a little bit like climbing. Okay. You're basically putting lots of little anchor points in, and it means that if you break your code completely, okay, if you make some big mistake, you can always go back to the version that works. Okay, so once you've added something and you're kind of happy with it and it works, then we make a commit. Okay. And if you break it at any point in the future, you can always go back. Okay. The other thing that commits are useful for is sort of showing you and other people how you got to your sort of final version of your code. Okay. If you don't commit often, then what it looks like is you started with a blank file and then 6 months later, just all of this code appeared. Okay. But committing often is nice and safe. Okay. But it also gives you a little bit of a record. And if you write nice messages to yourself, then a bit of a record of what you were thinking when you were doing different bits of code and when you were sort of making decisions. Okay. So we want to commit files, and ideally we want to commit our changes often. Okay. So yeah, it's I don't always follow my own advice, but commit often. Okay, if you make frequent commits, it's easy to roll back to the version that works. Okay, if you last made a commit 3 months ago, you can only the sort of previous place you can go back to is 3 months ago. Okay, so if you commit often, it's easy to roll back to a slightly different earlier version. Okay, so committing changes or committing files is something that happens locally on your laptop. Okay, so you've made some change, you think, okay, I'm happy with that, and you commit that. Okay, so you sort of commit that change and say, okay, that's done. Okay. Once you've made quite a few changes, okay, once you've made a sort of series of commits, it's quite useful to then push those changes up to GitHub. Okay, so we've made our commits locally on our laptop, and then we've got a bunch of them together, and we want to push them up to GitHub. Okay, and that means that other people who are working on the same project are able to see all of those commits that you've made. Okay, when the commits are just on your laptop before you've pushed them, only you kind of know about them. Okay, so other people can't see what changes you've made until you push them to GitHub. Okay, so it's always kind of a two-step process. Okay, we make commits, usually make quite a few, and that sort of stores what we've done on our laptop, and then we push those changes up to GitHub. Okay, okay. So what we're going to do is we're going to look at how do you commit some changes. Okay, we're going to look at something called git ignore files. Okay, and then we're going to look at pushing changes. Okay, so if we head back to RStudio. Okay. Depending on what options you picked when you were making your repository and how your GitHub is set up, okay, you might be like me here, and there'll be something that says no branch. Okay. If you pick to create a README, you might see something here called main or maybe master. Okay. So we'll come back to branches in a little bit later. But branches are kind of just thinking about which sort of version of code we're currently working from. Okay, so if you don't currently have a branch, we want to make one. Okay, and we want to make sure we sync the branch with the remote. Okay, so if you have this unticked, that just makes it on your laptop. It's always ticked by default, and that basically sends it up to GitHub in the background automatically. Okay, this is not working. Um, now you get to see me debug Git. Actually, should be. This is okay. It's not the way I usually do this, but okay. That worked. Okay, I might come back and fix this in a second. It is actually around about an hour in, so I did wonder if people wanted a 5 minute break kind of before we join in, just to grab a cup of coffee or some water or something.
Yeah,
Perfect.
absolutely.
All
Why
right.
don't you take 5 minutes to figure
Yes.
out?
Yeah. All right.
I can also, I'll pause the recording too.
Perfect. Thank you.
Okay.
Okay. So question in the chat is if you want to host your portfolio on GitHub, how can you ensure that only the latest version is visible without showing previous iterations? It depends what you mean by portfolio. So the idea of GitHub is it does show the full history of the code. What you can do, and something I might mention again at the end, is use something called GitHub Pages. Okay. So what you can do is you can sort of build a website that hosts your portfolio, and it builds that website directly from the code on GitHub. Because it's a website, you're only going to see the sort of current version of the website. So you can make the website public, but the GitHub repository behind it private. Okay. So that means that only you would be able to see the code on GitHub, but anybody could see the website with your sort of portfolio on it. That's how I typically do it if there's something that I want to sort of share with the world, but I want to keep all of the messy source code hidden away to myself. You do have to get that functionality on GitHub. I think you do have to pay for the sort of pro account, but it is quite cheap. I think it's like $4 a month to be able to have private repositories with public websites. Or you can use other sort of things like Netlify or sort of QuartoPub, for example, to host the website on. All right. So let's get back to it. So before the break, we were having a little look at committing some changes, and we're going to look at git ignore files and then pushing changes. Okay. So when we made our GitHub repository, what you saw before the break was me with a little thing here that said no branch, and when you go new branch and you give it a name, you get an error message. Okay. The reason you get that error message is because you sort of have an empty branch with nothing in it, and you're kind of trying to send that up to GitHub, which is also empty with nothing in it, and it's kind of doing the sort of message of, well, what do you want me to do? You want me to send nothing. Okay. It turns out what RStudio very kindly does is that as soon as you actually commit some files, it creates this main branch for you. Okay, so what we're just going to do is start by committing the files that were sort of generated by RStudio. Okay, so you should have two files here. So you would have your .rproj file, okay, and you would also have a gitignore file. Okay, I committed my gitignore file to when I've tried to figure out how to fix this error, so I've only got one. Okay, but what we do is you tick the little checkbox beside it, okay, and you'll notice that this sort of status goes from a question mark to an A. That's sort of saying it's been added. Okay, this is a file I want to commit. Okay? And then you click commit. Okay, and you get this sort of preview here. Okay, so this on the top left is just another copy of what's down here. If you've got multiple files that have changed, you'll see them all here. Okay, and this at the bottom shows you what are the changes. Okay, so in this case, everything is green. Anything that's green is something that's been added. Okay, so we made a new file and it has these added lines. If you were to delete a line from a file, you would sort of see it in red here. And what we need to do is add a commit message. Okay, so up here in the top right, we need to type a little message that explains what are these changes that you're committing. Okay, so I'm gonna type a message that says initialize project. Okay, I sort of set up my project, and these are the project files that I'm committing. You can't leave a blank commit message. Okay, you have to write something. I would advise you to write something useful, but I also recognize I don't follow my own advice. And if you go to the GitHub repo where I committed the gitignore file, it does just have a commit message that says test. Okay, so a lot of my commit messages end up being sort of test or try again or trying to fix this. Okay, but don't be like me, write useful things. Okay. And when you click commit, you get this sort of little message that says it's been committed. Okay. And what you should see is that your branch is ahead of main by one commit. So we've made a commit. Okay. So what I'm going to do now, we've committed one file. What I'm going to do is suggest we commit some more files. Okay. So if you don't have some R codes to hand or some data to hand, if you head over to the workshop website and you can go to examples or exercises, there's some data files and there's an R script there that you can borrow. Don't worry if the code doesn't make any sense. We're not going to run the code. Okay, we just want to have some files. Okay, so we're gonna save our R file. Okay, so just right click and make sure you save it into that folder where your Git repository is. Okay, and I'm going to do the same thing with the data. Okay, so what you should see. Okay, so if you open up your downloads, okay, I'll just move this over. Okay, you can see there's quite a few files in my downloads folder. Okay, I've got my R project file, I've got a gitignore file, I've got, you might see your .git and rproj user folder. Ignore those. Okay, we've got the R script I just downloaded and a CSV file of some data. Okay, and you can see that because I've just added these files in to my local repository, they kind of show up in RStudio with little question marks of you know, what do you want to do with these? Okay. So yes.
There is one error message in the chat that I wasn't sure if you recognized it or not from Carolyn.
True.
See that under, did that go out well
Yeah.
for everyone? Who's following along? And then Carolyn said she got this.
Oh, that's
Did you recognize
interesting.
that?
Um, um, it's not one I've experienced. I want to say it's something related to authentication. So GPG keys are usually related to how you sort of verify commits. Um, yeah, it's a good question, Libby. If it's a work laptop, you can sometimes have um problems passing things to and from GitHub. I have multiple laptops for that reason. Um, okay. Um, yeah,
Okay.
I'll leave that sitting there and hopefully we'll figure that out. Okay. So we've got a couple of files that we've added. Okay. So we have our R script. Okay. And we also have a CSV file with some data. Okay. Now let's say that it's secret data is sort of data that I can't share. And even with a sort of private GitHub repository, I probably, don't put confidential information sort of on GitHub like that. So what we want to do is we want to keep our CSV file in this folder because it's a useful place for it to be and it makes it really easy when we're working with our R code. But I never want to add it to GitHub. Okay. And so one approach would be to just make sure you never tick that box. Okay. That's not a great approach because when you've got lots of files, it's super annoying to have to be careful about what you do and don't tick. Okay. So that's where this git ignore file comes in. Okay. So you should hopefully see it in your list of files. Okay. You can click here. Okay. So when you open up that .gitignore file, you'll see that it's already got some things in there. Okay. And again, that comes from RStudio. When you clone a repository, it sort of says, okay, here's some files that are quite often generated by R or by RStudio that we generally don't want to add to GitHub. Okay, so it sort of git ignores them for you. And all the git ignore file is doing is saying, I have these files in my folder, let Git completely ignore them. Okay, so they still exist in the folder, but Git sort of doesn't see them. So if we wanted to ignore this CSV file, okay, so it's called LOS because it's looking at length of stay. So if I added that file name to that folder and then click save, okay, you'll notice that that CSV file sort of disappears from my Git panel. Okay, so Git doesn't see it anymore. Okay. What you can do in git ignore file is use something called wildcards, which sounds a lot more exciting than it is. So let's say that I don't just want to ignore one specific data file, I want to ignore all CSV files. Okay, and that saves me typing out the name of every single data file I have. So we can simply use a wildcard. Okay, so an asterisk .csv. So this is anything that ends in .csv. Okay, and you'll see that it's still ignored because los.csv fits this pattern. Okay. So what we can then do is then commit these changes. Okay, you can choose whether or not you commit them together or as two separate commits. Okay, so we might just say add analysis script as our commit message. Okay, and we click commit. Okay. So at the moment, all of these changes are just happening on my laptop. Okay, so I've made multiple commits. And what I want to do now is push them up to GitHub. Okay. And to do that, we simply click push. Okay. And it'll sort of bring up this little message to tell you where it's sending it. And if you go back to your GitHub repository, okay, and you sort of refresh the page, what you'll see is those files that you added. Okay, so you've got your gitignore file, Okay, you got your R script, your R project file, and crucially, no data file. Okay, and one of the nice things about keeping this gitignore file on GitHub is it also makes sure that no one else accidentally uploads the data as well. Okay, so yeah, we've made some commits and we've pushed things up to GitHub. So now I or anyone else can see the code that I've added. So if you are joining in, commit the initial files that you created when making a project. So that gitignore file and the R project file. Okay. If you want to go a step further, you can download some data or an R file from the workshop website or use some of your own code and make some commits and then push them up to GitHub and then check it's there. So head over to GitHub and actually check your files are where you expect them to be. Okay. So I'll give you a couple of minutes to work through that.
Again, if you have any questions about any of that, please let us know. I just keep writing down the time, Libby.
It's one of those things I never know how long it's going to take. And I think this exercise as well, you can make one commit and push it and it might take a minute. Or if you want to make lots of commits and things. Yeah. I do feel like the timer should I should write some code to automatically get it started. But yeah, let us know how you're doing if you're getting stuck or getting any error messages. We'll try to help. Equally, if you're all sitting there and you've made all your lovely commit messages, do let me know if you're kind of ready to move on to the next section.
I see some thumbs.
Okay. We will move on to the next part. I think we might be getting a little bit squished for time. So we'll move on. But if you are getting stuck, do just drop a message in the chat. So what we're going to talk about now is working in branches. Okay. So I've mentioned the words branches a few times. And what this kind of relates to is multiple people making changes. Okay. So far we've made some commits and then we pushed them up to GitHub. Okay. And you can imagine if you're working in a team of people, okay, you might have, 4 or 5 people all trying to push their changes and all kind of trying to push their changes to the one place on GitHub. it's going to get quite messy quite quickly. Okay, so what we typically do is we make branches. Okay, so branches are basically where you take a little copy of the code that exists, you make your changes to that little copy, and then you merge your changes back in. Okay, so there's a couple of reasons why this is useful. The first one is it means you can't break the thing that works. Okay, so generally the thing that's on either called master or main, okay, that's the sort of main version of the code. It's usually, well, sometimes working, right? So you might not want to make any changes to that until you're sure that your changes will work. So if you take a little copy and do your edits in your branch, okay, so in this little blue branch, if they don't work, you can just throw them away and you haven't broken anything. Okay. The other reason it's useful is because other people can keep making changes and they can make their own changes on their own little branch and sort of merge them back in. Okay. So the idea of branches is that usually we're sort of taking a little copy, making a specific change, and then we merge it back in. Right? So again, good practices for branching, okay, is that usually a branch is for something specific. Okay, so it's to add a particular feature or to write some code that fits a particular type of model. So we want to use a descriptive branch name. Okay. What I see sometimes is people make branches for themselves. So rather than branches relating to a particular feature, they're sort of like, oh, this is Nicola's branch, and I do all of my work in this little branch. Okay. It's not a great approach because it makes it harder to merge your changes back in. Okay, so we want to regularly take your little branch and merge it back in with that main branch. Okay, because otherwise you get sort of further and further away, and the branches get more and more different, and it's much harder to sort of merge them back together. Okay, so if we make branches for a specific thing, you're probably editing fewer files and you're more likely to merge it in regularly. Okay. I would also say delete merged branches. Once you've finished your feature and it's been added in to the main version of the code, you don't need to keep your little branch anymore. Okay, the record of everything you've done is still there, so we can just delete it. Okay, and that helps keep your GitHub repository nice and tidy. Okay? You don't want to be looking at your GitHub repository and be seeing hundreds of branches and you have no idea what they're for or when you edited them. Okay? So what we're going to look at now is creating a branch, making some commits to that branch, and then how do we get them back into main? Okay, so if we go back to RStudio, okay, we're going to come back down to this little new branch button that we looked at earlier. Okay, so we're going to give our branch a name. I am gonna call it add model, okay? Because I'm gonna edit an R script which adds another model in. Okay. Again, what we want to do is we want to make sure that this little checkbox to sync the branch with the remote is checked, and that basically makes the branch locally on your laptop and also makes the branch on GitHub. Okay, it saves you having to do it later. Okay, so when you click create, okay, you might get quite a long looking message. The key thing you'll see at the top is it is switched to a new branch called add model. Okay, and you'll see here, okay, you can see my local branches. I have main and I have my new branch add model. Okay, and I'm currently on add model. Okay, so now I need to make some sort of change. Okay, so if I go into my let's say analysis folder and make some sort of change. Okay. It really doesn't matter at this point what the change is. It can be anything you like. Okay. But you see that I've made a change to this example analysis.r file, and it's come up to say I've made a change. So I want to commit that. So we do the same thing we did earlier. Okay, tick checkbox, click commit, and we add a message that says add model 5. Okay, and then I might make some other changes, or I might just push this change up. Okay, so I click push. Okay, so I've made a new branch using this new branch folder. Everything else is exactly the same as before. Okay, we made a change, tick the file to add it, commit it, and push the changes. Okay, and now when we head up to GitHub, okay, you can see already it's saying that 3 seconds ago I added some changes. Okay, so this is saying that I've got a new branch called add model, and I recently pushed some changes. Go ahead and click the compare and pull request button and click create pull request. Okay, so what a pull request is essentially you are making a request that the changes that you've made get pulled into the main branch. Okay, so you can see all of the open pull requests here. Okay, if you miss the little make a new pull request box in orange, you can always make one yourself, clicking new pull request. So we go into our pull request. What you see is you get a list of commits. Okay, here I've only made one, but if I'd made sort of multiple commits, maybe made multiple changes, I'd be able to see when they were made and maybe who by as well if there was multiple people working on it. And you can also see all of the changes. Okay, so a little bit like in RStudio, anything you've added is listed in green, and anything that you've deleted would be shown in red. Okay, so it's just one sort of little addition here. Okay. And there's a couple of things that you might need to check. The thing you want to see is this lovely message here that says no conflicts with the base branch. Okay, that means that none of the changes that you've made conflict with any changes that anyone else has made on main while you were doing your work. Okay, if there's no conflicts, that's great. And what you can do is just click merge pull request and confirm the merge. Okay, and you get sort of prompted to delete that branch. Okay, we don't need it anymore. Okay, and if you head back to the sort of main page for the repository, okay, you can see my latest commit message is there. Okay, and on main, I've got my additional model. Okay, so that's how we make branches. Okay, it's quite similar, other than the sort of start and end. Okay, you make a new branch, then you just follow your normal workflow of making commits and sort of pushing changes, and then when you're kind of ready, you can add your code into the main branch, sort of into your main code by making a pull request. Okay. So if you want to have a go at that, please feel free. Okay, you can make a new branch from RStudio, make an edit to your R script or your gitignore file or add a file, and then push your branch to GitHub and open up a pull request. Okay. And what we'll do after this section is look at what happens when you make a pull request and you don't get that nice little no conflicts message. How do we try to fix that?
Awesome, and you have one question in the chat, Nicola.
Yes. Um, so using VS Code with GitHub on a virtual machine, is that question? Oh, yeah. Yeah, so I think the question is sort of how do you do the same things that we're doing in RStudio in VS Code? Um, VS Code does look quite different to RStudio in terms of the sort of Git layout. It's kind of got a panel down the side. So rather than seeing your kind of list of files at the bottom, it has a sort of tab on the left-hand side that shows you all of the changes. But it does kind of have um, sort of, I think it's like plus signs rather than checkboxes. But then you can sort of add commit messages at the top. So it does have similar functionality. It's just the buttons look a bit different, might be called something slightly different, and are in a different place. Um, what I might recommend is also having a look at positron as well. So if you are an R user and you're kind of struggling with VS Code, it's kind of it it looks kind of similar to VS Code, but it's a little bit more R friendly. So it might be that kind of nice in between stage, where you're not having to learn a new Git layout and learn a sort of how do you work with R in this thing at the same time.
All right, if this section's going well for you, please also give us a thumbs up too. I saw a few thumbs up. I don't know how we're doing on time, Nicola, if you wanna keep moving.
Yeah. Um, yeah. So what we're going to do is so we've got about 25 minutes or so. So the next section we'll do looking at conflicts. So what happens when you unfortunately have to deal with some conflicts because some other people have made changes to what the same sort of lines you were working on. And uh, this our section after that, we'll just talk about some sort of good practice, or if people have sort of general questions or things they may be finding hard with GitHub, we can talk about those. Okay. So let's talk about Git conflicts. Okay. So Git conflicts happen when you've made a change. Okay, you've committed a particular change, and someone else, or indeed you at an earlier point in time, have also made a change to the same file, and they conflict with each other, and GitHub sort of goes, well, which one do you want me to use? Okay, it does sort of force you to decide that it won't sort of pick, the first one or anything like that. It will tell you, okay, here's the two changes, which one do you want? Okay. GitHub is quite good at dealing with conflicts by itself to some extent. So if I edit a file and someone else edits the same file, as long as we don't edit the same line of the file, GitHub knows that's not a conflict. Okay, so we've got a big long file, but maybe someone's writing the introduction and I'm writing about methods or making some plots. Those are two kind of separate sections of the one document. So GitHub's like, well, you haven't edited the same bit, so that's fine. Okay. Conflicts only really happen if you edit literally the same line of a file. Okay. So what we're going to do is we are going to make a conflict. Okay. So the easiest way to make a conflict is with someone else editing the same file, but it can be you, and quite often when I'm writing code, it is me making conflicts for myself, unfortunately. So you can kind of think of the GitHub .com interface as almost being like someone else on a different laptop. Okay, so if I came along and made an edit to this file, okay, so what I'm going to do is I'm going to say instead of loading all the tidyverse, let's just load dplyr. I'm going to commit those changes. Okay, so this change has happened. Okay, online. Okay, this change doesn't exist on my local version. Okay, so let's say I made a new branch. Okay, so same as earlier, and I'm going to call it update packages. Okay, because I think I'm making a new branch, and I'm going to go and update the packages we're using. Okay, so this is exactly the same as before when we were creating our sort of add model branch. Okay, I'm going to go in here and say in here, instead of loading the tidyverse, I'm going to load tidyr. Okay, and what I'm also going to do is I'm going to make a slightly different change here. Okay, just to kind of show you how GitHub resolves some conflicts but not others. Okay, so I've made two changes to this file. Okay, I've gone from library tidyverse to library tidyr. Okay, and I've added theme minimal onto one of my plots. Okay, so I then commit this file. Okay, and I push that. Okay. So then if I go up here, okay, I get a similar message as before saying, do you want to make pull requests? Okay. And you can see that I'm already getting some horrible looking message. I get a sort of big red cross that says can't automatically merge. It does tell me not to worry about it, which I appreciate. Okay. So we go ahead and make our pull request anyway. Okay. But what you'll see is that I can't actually merge it, right? This merge pull request button is grayed out and it says it's got conflicts that must be resolved. Okay. There's a couple of different ways to resolve these conflicts. And sometimes it depends how big those conflicts are. Okay. So what you might want to do is look at the files that have changed, or have a little look at resolve conflicts. Okay. So if we click resolve conflicts, it opens up this kind of web editor for dealing with your conflicts. So first thing to notice is this was one of the changes I made. It looks fine. Okay, no one else edited that line, so this is totally fine. What it does do is it highlights where these conflicts are. Okay, so it says this is what's currently on main. This is what you've tried to add. Sort of highlights them with some arrows and some lines dividing them. And it's basically saying, I need to edit this file and decide which one do I want to keep. Okay. And you don't have to pick one or other. Okay. You can, at this point, you could write something entirely new in here if you really wanted to. Okay. So let's say I want to keep both tidyr and dplyr in there. Okay. We want to make sure we remove all of the sort of arrows and equal signs. Okay. And we can check through. It's always useful to sort of scroll all the way down to the bottom to make sure there's no conflicts hiding at the bottom. Okay, but then you can sort of mark that as resolved, right? And then click the green button to commit that merge, and it's taking its time. Okay, so at the moment, I'm still in the pull request. Okay, all I've done is I've added another commit that sort of says I've fixed the conflict. Okay, but now you'll see I don't have any conflicts. Okay, so I can go ahead and merge that pull request. Okay, and that adds my update there. Okay, so if I go back to main now, okay, you can see both packages are in. Okay, so assuming that your conflicts are quite small, I think that is the easiest way to sort of do it. It saves you having to try and pull both sets of changes down to your laptop and work on them. Um, it is as long as the changes are conflicts are small, I think this is quite a nice way to kind of interact with them. Um, in terms of conflicts, so someone there was a question earlier about uploading outputs. So if you have an R Markdown document and let's say you're making like an HTML file, do you upload the outputs as well as the .rmd file? You can, but what I find is that if you are uploading those HTML files or anything like that, you're likely to get way more conflicts because there's always sort of lots of little things that are Markdown or Corto changes in the background that you probably don't care about. So not uploading them kind of helps to avoid conflicts. And I think that's probably my main reason for not uploading them to GitHub is so I have to deal with conflict less. Okay. The other things that help you avoid conflicts is sort of, committing files regularly and merging branches regularly as well, rather than sort of, waiting 6 months after making your branch to add anything else in. Okay. So we should have enough time to have a go at this. So what I would suggest is that um, you don't necessarily need to go ahead and make yourself a whole new pull request and a merge conflict, but maybe play around a little bit with the web editor to just kind of get a feel for how that works and how do you sort of make changes to code from a web browser. Okay. So I'll give you a couple of minutes to kind of work through that. And again, do ask any questions if you have them.
If you feel good about everything, feel free to give us another thumbs up too. You're getting some thumbs.
Excellent. Okay. Yeah, we've got sort of 10 or 15 minutes left. So if you're still working through this exercise, feel free to kind of keep working through that. The last sort of section, I just want to talk about some stuff that's kind of useful and kind of good practices that you might want to think about if you're using GitHub. So we kind of started this session by thinking about the idea of emailing files back and forth and asking for feedback and adding comments. And one of the reasons you might want to use something like GitHub is to make that sort of reviewing and sharing process a little bit easier. Okay. And there are other things that you can do before you share it with someone else to make it even easier. Okay. And one of those things is writing what we call a README file. So these sort of readme.md files are special files on GitHub. Okay, so when you go into a repository, you might see some text or some explanation about what that code does. Writing a README file is a really useful thing, right? All of the things that you think are obvious, um, whether it's someone else reading your code or whether it's just you in 6 months, those things might not seem so obvious. So things like, for example, even the fact that it's written using R might be something that you want to write down. Things like what version of R, where are you storing the data relative to the project? Are there any particular sort of setup? If there's multiple files, do you have them in a particular order? All that kind of thing. The stuff that's in the back of your mind of, I know this is my code, just write it down. You will thank you in the future, right? So yeah, explain information about what the project is as well. Okay? It's particularly useful if you are sharing it publicly. Okay, if it's a public project, give it a nice description, a bit of a title. If it is a public project and you might want other people to contribute to it, okay, so you'll see this really commonly with some of the widely used packages, so things like ggplot2 and dplyr. If you find a bug or there's a bit of an issue and you want to contribute a fix, how should you do that? So if you're making something public and you think, okay, I want other people to help with this, give some instructions about how they would be able to help you. Okay. We probably don't have time to go through an example of this, but when you're making a pull request, you might see an option on the right-hand side where it says reviewers. You can ask for someone to review it, okay? And this is sort of really nice because you can kind of wait until your pull request is ready. You don't even have to sort of send someone an email and say, okay, my code's ready for review. They'll get a notification from GitHub and they can leave comments. And so you can track through those discussions with the code. Okay. And Jack Kennedy has a really nice blog post about code review, particularly sort of code review for people who are doing like data analysis or statistics, which I think is a really nice resource because a lot of the code review guidance you might see online is sort of related to like software engineering and building apps, whereas this is kind of if you're reviewing someone's code or you're asking someone else to review your code, what should you be looking for? Some other useful GitHub features that we kind of touched upon a little bit, okay, are GitHub issues, or GitHub discussions. So GitHub issues, okay, if you go back to the GitHub repository, okay, you can make an issue, and this is basically your to-do list, okay? So you could add, say, Model 6, and you can add some description about exactly what Model 6 should have, and then you can click Create, okay? And you'd have some description. You can sort of tick it off when you're done, and you can also link pull requests to issues, okay? So if you see an issue and you think, okay, what I'm going to do is I'm going to make a branch to add Model 6, and then I'm going to make a pull request to merge that branch in. You can link it to this issue, so your kind of to-do list links up automatically with the work that does the thing on the to-do list. So it's a really nice way of keeping track of everything, and it's quite nice to, if you do like ticking things off to-do lists, like me, is sort of getting those all ticked off. There's been a few questions in the chat about sort of things related to portfolios. And there's what you can do, which is a really kind of easy way to kind of start a sort of portfolio, is to create a GitHub profile README, right? So if you go to GitHub, and if you create a repository that has the same name as your username, this is kind of a special repository, okay? And you can add a README file with some information, okay? And that appears sort of on your GitHub profile. So it's kind of a really reasonably easy, quite quick way to sort of say, this is what you'll find on my GitHub. These are the kinds of projects I'm interested in. Okay. There's also GitHub pages, again, sort of related to portfolios. If you want to build a website that might be with R Markdown or Quarto, you can deploy that with GitHub pages for free. So it's a nice way to sort of automatically create websites and kind of host some of that portfolio for people. And there's also GitHub Actions, which again I mentioned right at the start. So GitHub Actions is a nice way to automatically run some of your code. Okay, so you can, let's say, have an R script that runs once a week. You can get GitHub Actions to run that R script for you. So it's really useful if you got sort of tedious jobs like package checks or sort of a weekly report. You can get GitHub to do that for you, which is always nice. Okay. And just as a reminder that all of the workshop resources for today are online. And if you go to the resources tab, there's some other links there as well. So there's a Happy Git with R book, which we've used a few times today. There's also this book by Bruno on reproducible analytical pipelines. So that's quite good if you're thinking about particular things in terms of package versions. If you're sharing code with someone else that's using a different version of packages, how do you deal with that? I also really like this, what they forgot to teach you about R. So if you're kind of interested in things like projects and kind of making your life working with R a little bit easier, that's quite a nice way. And there's another few links here around, particularly around research and how do you make research reproducible and use Git and GitHub as part of that. Otherwise, that does bring to the end. We do have 5 minutes left for questions if anyone does have any burning questions they want to ask.
Thank you so much, Nicola. I'm going to go ahead and stop the recording.